All right, hi everyone. Welcome to my channel. If this is your first time joining, my name is Shane and this is the Coding Zoo. So at the Coding Zoo, our goal is to help others learn how to program like yourself. So if this is your first time joining and you enjoy these videos, be sure to click subscribe, click the like button. That helps us get the word out to others. In today's video, we're going to start covering data structures. The first data structure we're going to cover is an array. So if you've never used an array before, you're new to computer programming and you're new to data structures, the first one you want to start learning about is an array. So we're going to cover array. We're going to let you know what an array is and how to use it. So if that interests you, stick around. We're going to jump right in. All right, so let's go ahead and get started. So first, what is an array? So in computer science, an array is basically just a collection of data values. So for example, if I create a variable, if I create an int variable and an integer variable that stores a number, I have one variable which stores one number. Well, how would I store multiple numbers, right? How would I store multiple values in one variable? Well, that's where you would use an array. Let me show you real quick. So if you look at my desktop here, I've prepared a few examples. I'm going to go over these examples one by one. So if you look at this first example, I basically have declared a number variable. So in my number variable here, I have the integer 3. So this is basically me creating a single variable and storing one value, right? I'm storing the integer 3 in the variable called number. All right, so what happens when I create this variable? What are you doing? Well, you're basically telling the program to store this value in memory, right? So picture it is creating a slot in memory and storing your value there, okay? You're allocating memory and you're putting a single value in that memory. So what happens when I want to store more than one value in a single variable? Well, you can do that by creating an array. All right, so let's take a look at how I would create an array. Let me uncomment this code. So here is one way you can declare an array. So what am I doing here? So first I'm declaring what kind of array is it. It's an integer array. So I have integer, and I have open bracket and close bracket. Then I declare my variable name. I'm calling this array my array. And I've got equals, and then I have open squiggly bracket. Can't hardly say that, squiggly. Open squiggly bracket. And next I'm saying what is in my array. In this array, I'm going to store 0, 2, 3, and 4. And then I'm going to close it with another bracket. And then I'm going to have my semicolon. So I went from having a single variable that contained a single value to a single variable that contains multiple values. So my array is allowing me to store multiple values. Now, one thing you should know about an array is when you define an array, it has an exact number of elements it can have. So it doesn't grow. Once you declare an array, it can only have that many elements. So in this declaration, I have 0, 2, 3, 4. I'm putting 4 elements in there. So when I declare this array, its size is going to be 4, and it will never grow any bigger than that. You can't have more than the original size. This is the original size. So the size is not dynamic. It stays at what you first set it at. So as I declare my array, I may give it a size, or I may specify the elements that I want in the array, and it's going to make it have a certain size. Now when I do that, Java's going to, or most programs are going to create that array in memory, and they're going to allocate just enough blocks, just enough consecutive blocks in memory to store those values, right? So if my array size is 5, it's going to open up 5 consecutive blocks of memory to store your value. And that's 5 consecutive blocks. It cannot grow, right? The downside of an array is it can't automatically grow. Here, let me show you some more ways of creating an array. Let's look at this example here. So in this example, I'm doing int, open bracket, close bracket, my array primitives, and I'm passing in 1, 2, 3, 4, 5 values. What's different about this array? Well, with this array, I just wanted to show you I can create an array of primitives. This is a primitive integer. So in our upcoming videos, I'm going to go over different data structures. One will be a list. Now, a list cannot keep primitive data types, right? I just wanted to point that out. An array can have wrapper objects, or it can have primitive data types. This is one example of an array that stores primitive integers. Now, what is another way of me creating an array? Let's go over that. So in my next example, I'm going to show you how to create an array without giving it the value type up front. So I'm going to comment these items out here. And I'm going to declare my array here. All right, so let's look at this piece of code. What am I doing here? So first, let's start with my declaration of my array. So up here, we declared an array by saying integer, open bracket, in bracket, my array, and then we gave the values we wanted in the array. And that array is going to be created with a size of 4. Down here, I'm not giving it the values at first. I'm just saying create me an array with a size of 4. So basically I'm doing integer, open bracket, in bracket, my array equals new integer, open bracket, the size of the array I want it. What's the size I want? And then in bracket, semicolon. So that's another way of declaring arrays. You can basically declare what size you want up front, and then you can put values in later. Now, how do you put values in later? Well, you do that by specifying an index. So an index is just at what point in the array do you want to put a value? An array is a zero-based index. So if I wanted to access the first element in the array, I would use the index of 0. So what do I mean by index? Well, this is how you do it. So I'm going to have an index. I'm going to start with 0. I'm going to go ahead and put that index in this variable called current free index, right? Now, I don't have to do this. I could just use 0 right here. So I could say, all right, for my array, the first slot, notice I have open bracket, the index, close bracket. I want to put the number 1. So I could do it this way. So my array index 0, put the value 1. That's one way of doing it. For this example, I'm going to use a variable to keep track of my index. All right. So first, my index is 0. So I'm saying in my array, put at index 0, the value 1. Now this plus plus here, and I don't want to go too deep into Java, but this plus plus is saying basically after I get my value out of this variable, add 1 to it. So by the time you get to this line here, I'm saying my array index 1, set the value to 4. And then next I'm saying, and I'm adding a number to this variable after that. And then in this line, I'm basically saying my array index 2, put it the variable 8. So 0, 1, so 0, 1, and 2 indexes, put 1, 4, and 8. This is basically what I'm doing with this piece of code. So this would be the same as me saying basically 0, 1, and 2. Right? This is how you could set those values without using a variable to keep track of the index. I like to use a variable to keep track of the index. Hopefully that's not confusing you. So the basic thing to note is if I want to put values in the array, I use an index. And it would be the array name, open bracket, the index, close bracket, and then equals whatever value you want to put in. Right? That's pretty simple. Don't get caught up on my current free index variable too much. Hopefully that's not confusing you. But here, I'm going to put it back. All right, so I'm basically in 0, 1, slot 0, slot 1, slot 2. I'm putting these variables. Let's print it out. So I've got a little helper method here I've created ahead of time that kind of just goes through the array and prints it out, right? So you'll see here I have this helper method. It prints out some text for me. And I'm going to loop through this array. Now, I'm going to loop through this array, and I'm going to print it out. I'm going to print out what's in the array. Now, I'll go through how you do this in the next example, next few samples. All right, let's run it. All right, so there we go. So what is in my array? So index 0, I have 1. Index 1, I have 4. Index 2, I have 8. And since I made this array to be a length of 4, my third index, which there's 0, 1, 2, 3, 4. So my fourth index, which is index 3, is null. So when I create this array, I create it to the set size, and it's going to stay that size. All right, pretty simple. Let's move on. Now, how do I get something out of my array, right? What's one way of getting something out of my array? All right, so in this example, I'm showing how do you get something out of your array. So we saw you use an index to put something in your array. Well, how do you get something out? Well, same thing. You use an index. So on this line here, I'm actually saying to print out whatever is in my array index of 2. So remember, it's 0 base, 0, 1, 2. So that will be the third item in my array, which should be an 8. Let's run it and see. So here's where I printed out the array above in the previous example. Here's where I'm printing out index 2, 0, 1, 2, and that happens to be 8, right? So I'm printing out 8. So I'm using an index to get data out of my array. You use an index to get data, put data in your array. You use an index to get data out of your array. Just want you to take note. If you know where the value is at in your array, you don't have to search the array. You don't have to traverse through the array like I did with that loop a second ago. If you know where it's at, you can just give the index value and you can get the value out. That is called constant time. How fast you do that is called constant time. It's big O of 1. I won't go into the details of big O, but if you're familiar with big O, this is constant time. If you know what index the value is at, it's constant time. That is O of 1. All right, let's move to the next one. All right, now what if I wanted to search through the array for a value, right? How would I do that? How would I search the array of value? I want to print something out, or at least want to find out if the value exists in there. How do I do that? Well, you would loop through the array. You'd go one by one through the array, looking for the value you're searching for, basically, right? You'd loop through the array. Now you do that big O of n, linear time. That's linear time. So let's search. I'm going to search for the value of 8. So I'm going to create a for loop here. Now I'm just going to start with the index of 0. So for, I've got open parenthesis, int, index equals 0. I'm going to start with the index of 0. Now and then I've got semicolon, index. I want to keep going as long as index is less than myArray.length. So you'll notice there's no open and close bracket next to length. This is a property. This is not a function on the myArray object, right? It's a property. So if you need to know the size of your array, if you didn't already know that it was a size of 4, you would use your variable name dot length. So I'm saying, okay, I'm going to start with the index of 0. I'm declaring that index right here, int index of 0. Keep going until index, as long as index is less than myArray length. And then each time you loop, increase index by 1, index plus plus. Index equals index plus 1. It's basically what you're saying there. So loop through there. In this loop, I'm saying if myArray, and we're going to start out with index 0, 0 is not equal to null, and myArray index 0 is equal to 8, print out found, not 2, but found 8, and then it is at index and then the index number. So I'm going to loop through, going through each index until I find 8. And when I find 8, I'm going to print it out. Let's see how that works. So here is this example right here. So I'm searching for 8, and it looped through the array until it found 8. It says I found 8. It is at index 2. So it kept looping until it found 8. And as you can see in the previous example, 8 is at index 2. So we were able to search through the array. We were able to loop through the array. It's linear time, big O of n. I was able to loop through the array, search for something, and I found it, and I printed out the index number where it exists. Just wanted you to understand, how do you loop through how do you search an array? You basically loop through the array one index at a time, and you look for something. That's how you search through an array, right? Linear time. So what's another way I can loop through my array? I loop through my array using this type of for loop. Is there a different way of for loop I could do? Sure. I could do for integer value my array, and then do sys out. Let's do that, value. So I could loop through my array this way. I don't have to use the index. I can use this type of for loop. For each value in my array, print out that value, right? Let's run that real quick. So this was my previous example. Here is where I'm looping through with that last for loop. For each value in my array, print out that value. Here's where I'm looping through for that. You can traverse your array. You can search for something in your array. You can print everything out in your array. If you don't know where the index, if you do know what the index is, you can grab it real quick, O1 time, constant time. If you don't know where it's at, or you're searching for something in your array, or you just want to print out your array, you can loop through it. That is linear time. Big O of n. All right, next let's take a look at inserting more data in the array. So I've already put 3 values in my array. I can put one more value because my array is size of 4. Now how would I do that? You've already seen this above. I just use the index to do that, right? So I've already got an index variable. I've been keeping track of what index is free with my index variable. I know that this variable represents what index is free, because I've been adding 1 to it and using it to store values, right? That's why I created that variable. Keep track of what index is next. If I didn't know what index is next and what index is free, I'd have to loop through that array and find the empty slot. But because I've been keeping track with this variable, what index is free, I know which slot is empty. 0, 1, and 2 have something in it. Slot number 3 doesn't. In this case, I don't need this plus plus. Current free index is already set to 3. I'm going to set that variable to 9. Now, because I know what index is free, this is big O of 1. This is constant time to do that. If I didn't know what slot is free, I'd have to loop through it, find the empty slot, and then set that slot. That would be ON, linear time. Let's run this. I knew what index was free, and I put my 9 in there, and I was able to print it out. So I have 0 index of 1, 1 index is 4, 2 index is 8, and the third index is 9. If you know what index is free, you can put something in there fast. O1, constant time. If you don't, you have to search. ON, linear time. One last thing. What happens if you want my array to store more than 4 elements? What do you have to do? Well, you have to create another array, take your elements out of your my array, and store them into your new array. And that second array you create it with more slots. So you have to manage that yourself. And that's tedious and time consuming. All right. So as the elements grow and how much you need to store, you have to keep creating new arrays. So one of the downsides of using fixed arrays, the downside is you have to do that managing of creating new arrays and copying stuff over manually. Something like an array list, a dynamic array, which is sometimes called an array list, will do that for you. All right, in my previous lesson, we covered arrays. In this lesson, we're going to go over lists. We're going to go over specifically array list. So what is a list? In computer science, a list is an abstract data type that represents a finite number of ordered values, where the same value may be in the list more than once. That's a key thing to remember. The same value may be in the list more than once, right? So what's the difference in a list and an array? So as we go over this list, I'll kind of point those things out. All right, so on my desktop here, I've got a few examples. Let's go over them. So first, let's talk about how to create a list. So right here, I'm creating a list called ages. Now, ages is an array list. I'm creating an array list. Now, you'll notice I have list, and I have less than sign, integer, and the greater than sign. So I'm creating a list, and I'm going to store integers in that list. So when you're creating a list, you can specify exactly which type you want to include in the list using generics. Here I'm specifying I want to store integers in the list. So what is list? Well, I mentioned earlier, list is an abstract type. So what does that mean? Well, in this case, that means it is basically an interface. If I go inside of the list, you'll see that Java has implemented an interface called list. So list is an abstract type. Underneath that abstract type, you can have all kinds of different kinds of list, concrete types. In this case, we're going over array list. That's the concrete, less abstract type, array list. I'm creating a list of integers called ages equals new array list, and you'll see my less than and greater than side, and then you'll see my open and close parentheses. So this is generics. Generics lets you specify what type you want to store in the list. Now, one thing I want you to take note with arrays, we covered in our previous lesson, arrays you can store basically a collection of primitive types. Can you do that with a list? Let's look at this sample. So in this sample, you'll see I'm getting it cannot compile. You'll notice it has the line underneath it. No instance. It's basically this cannot compile. Why is that? Well, a list or an array list cannot store primitives. Unlike an array can store primitives. A list cannot. So it doesn't like this. It can't use this. This is an integer primitive. I'm saying store that in the list. Doesn't like that. It won't let you do that. All right, so that's just a key thing to note. You can only store objects in a list. You cannot store primitives in a list. Let's move on to our next example of creating a list. Here I've created a list of integers called ages. Let's look at another example of creating a list. All right, so here I am creating a what? A list of strings. So I've got list, less than sign, string, greater than sign. I'm calling the variable names equals new array list, less than sign, greater than sign, open parentheses, close parentheses, semicolon. So here I'm creating a list of strings. My variable is called names. Pretty simple. I'm creating an array list. Now, when I use this list keyword, when I use this array list keyword, just key thing to know, in Java, when you do that, you're bringing in objects, you're bringing in interfaces. You have to import them. So if I look at the top here, you'll see I have import Java util array list, import Java util list. So I'm importing those objects and interfaces to use. Okay, so I've created an array list. One thing to note about an array list is, well, what's inside of an array list? An array list is nothing but a wrapper around an array. So underneath, an array list uses an array to store data. Now, I mentioned in the previous lesson that an array has a finite size. When you first create an array, it's set to a certain limit. Well, array list, when you first create an array list, it creates an array, and that array is set to a certain limit. In Java, the default size is 10. So when I do equals a new array list, it sets it to 10. Now, I could make it a little different. I could say, hey, I don't really like that default, and I can specify my own size. So here I'm doing new array list, and you'll notice in my parentheses, I'm setting an initial capacity. I'm setting it to 3, right? I'm actually specifying my own size. An array list is basically a wrapper around an array. So why would you use an array list? Well, it does a lot of things for you. An array list gives you more features on top of an array. Let's go ahead and I'll show you how to add an array list, and I'll explain that more. So how do I add to this array list? Well, I've got this array list called names. I'm going to add names to it. So here I'm doing names add Shane. Here I'm doing names add Anthony. So names.add parentheses, and I put my string in quotes, in parentheses, semicolon. Pretty simple. If this was an integer, I'd do names.add integer. Put your integer there, right? Very simple. Names.add Nick, right? So I've just added 3 names to my names array list. Now I have this print list helper method that I created earlier. Let's take a look at that real quick. All it's going to do is it's going to loop through my array, and it's going to print it out for me. So we'll go over this in a few minutes, in a few seconds. I'm just using this helper method to basically print a label and loop through my array and print out what I just put into the array. And I'll explain how the loop works in a few seconds. I have my array of names. I've added 3 names to it, and I'm going to print it out. Let's run it real quick. All right, so here's my example. I have created an array list, and I looped through and I printed them out. Shane, Anthony, and Nick. So you can see here, it added 3 names to my list. Pretty simple. Let's move on to the next one. In this one, I'm going to show you how to get something out of the list using an index. So just like with an array, a list has a way to get values out of it by index. With a list, you do list.get, and you specify the index. All right, array lists are 0-based, just like arrays. So index 2, that would give me, well, Shane is going to be index 0, Anthony is going to be index 1, Nick is going to be index 2. So here I'm going to go to the names. I'm going to get index 2, and I'm going to print it out. Let's run it. All right, so in my example 3, get by index, I printed out Nick. And Nick is my index 2. I have index 0, index 1, index 2. Pretty simple. So I can add to my array list, and I can get stuff out by index. Very simple. Let's move to the next one. Now, before we move to the next one, I just want to mention, when I use this get, I'm using an index. I know exactly where I want to get something. If you have the index, getting data out of an array list is O of 1. It's constant time. It's big O of 1. Just wanted you to take note of that. So if you're familiar with big O, this is big O of 1. It's constant time. This is very fast to get something out of an array list using index. That's if you know what the index is. Let's see about looping through an array list and trying to find something. What if I'm trying to find Nick to see if Nick is in the list? I don't know what its index is. I don't even know if Nick is in the list. So I can't say names.get2. I don't know that Nick is at 2. Let's assume I don't know that Nick is in the list, and I don't know what index it is. So how do I search the list for a particular string? Here's one way of doing it. I can use a regular for loop. So just like with arrays, I can do for, and I can declare the index int index equal to 0. I can have this index to keep track of where I'm at while I'm looping, where I'm searching. I'm going to keep searching. Y index is less than names.size. So size tells you how many elements are in the array list. Index equals 0. I'm going to start with 0. I'm going to keep looping, and as long as index is less than the list.size, each time I loop, I'm going to add 1 to my index. Index equals index plus 1 is basically what this means. As I loop, I'm going to say, hey, names.get the index. Of course, the first one's going to be 0. So I'm going to do names get 0 index. I'm going to get that value. Does it equal Nick? If it does equal Nick, I'm going to print it out. Found Nick at index 0. If it doesn't equal Nick, I'm going to keep going until I find Nick, if Nick is even in the list. So this is one way to loop. This is one way to get data. If you don't know what the index of something is, but you know it might be in the array, you can search the array. You can traverse the array. This is big O of n. This is called linear time. Let's run it real quick. So this is that example. I found Nick at index 2. So again, it's 0-based index. Shane is at index 0. Anthony is index 1. Nick is at index 2, and it actually found it in the loop. So it just looped through here, it looped through the array list until it found Nick, and then once it found Nick, it ran this piece of code and printed it out. Pretty much just like an array. Now, is there another way to loop through a list? Sure there is. Let's look at that. So I've got another for loop. I've got a for each loop. All right, so for each string name in names. Do this right here. If name equals Nick, system out print found Nick. For every string in names, loop, put the value in this variable called name, and then you can access that variable name. Here I'm checking the name if it equals Nick, and if it does, I'm going to print it out. Pretty simple for each loop. So here's that example right there. Found Nick. This is the first one where it found Nick at index 2. Printed that out right there. Here's the loop where it says system out print found Nick. So it looped through that array and it found it. Here, let's show you another way of looking at that. I'm just going to print out everything in that list. So I'm going to do system out print line name. So for each name in names, print it out. Let's run that. There we go. Printed out the 3 names in that list. Shane, Anthony, Nick. So traversing an array list, very simple, pretty easy to do. Now, what's one difference with an array list versus an array? Well, I mentioned earlier that array list is basically a wrapper around an array, but adds on features of an array. It keeps track. An array list keeps track of what index is the next one that's empty. An array list keeps track of, is my array full yet? What does it do when your array is full? Well, if you manage the array yourself, you'd have to create a new array, copy data from create a new array, a bigger array, copy data from your old array, which is full, put the data into your new array, and throw the old array away. You'd have to manage and code that yourself. An array can't grow on its own, right? It's set to a certain size and it stays at that size unless you create a new array. Well, array list is different. An array list is basically a dynamic array. It can grow. It's smart enough to where it grows on its own. Here's an example. Now, you know that I set this array list to a size of 3 at the very beginning, and I put 3 names inside of it. So that tells you that array list is full. So can it grow on its own? Let's find out. So in this example, I'm going to print out the size, and I'm going to add 2 more names to it. If it grows on its own, if it's not stuck at 3, then my size should increase to 5. I'll go from size 3 to 5. We initially know that the array underneath the scenes is set to 3. That's what I set the array list size to, 3. All right, let's run it. An array list or list automatically grow. That's one of the benefits over using an array list versus an array. Automatically can grow. Started out with a size of 3. I added 2 names to it. I ended up with a size of 5. Here's my new array list. It has Shane, it has Anthony, it has Nick, it has Don, it has Christina. It has 5 entries. So underneath the scenes, my array list took care of creating a new array, throwing my old copying values from my old array into my new array, and throwing my old array away. It managed that for me. That's what's cool about an array list. It does things for you that you'd have to do yourself if you were using an array. That's a key feature of array list over using an array. Now, what if I wanted to remove something from the array list? How hard is that? How can I do that? Here, I'm going to do that by saying names, the name of my array list, dot remove. So it's going to search all the way through my array list, looking for what I'm telling it to remove. I'm telling it to remove Don. I'm telling it to remove a string. This is an array list of strings. I'm saying find the string that equals Don and remove it. It's going to loop through that and do that. Well, how fast is that? How long does that take? Well, that's big O of n. That's linear time. It's got to loop through there and find it. So it's linear time. All right. So I could remove Don from the list doing it this way. It's going to search for it. It's going to find, if it finds it, it's going to remove it for me. Let's go ahead and run that. Okay. In my previous example, you saw there were 5 elements in the array. In the array list, Shane, Anthony, Nick, Don, and Christina. Now, after I removed Don, and I printed out the array list right here, I told it to find Don and remove it. It found it. It searched the array in the array list object, found it, and removed it. Here I printed it out. What do I have left? Shane, Anthony, Nick, Christina. So now I have 4 items left. It found it and removed it. What's another way I can remove an item from an array? Well, let's comment this one out. And let's uncomment this one. Another way I can remove something from an array is I can do it by index. Now, you saw up here, that I can get something from the array by doing names.get and the index. I can also do the same for removing. I can do names.remove and the index. So since I'm not saying remove a string from this list of strings, I'm saying remove this integer. I'm saying remove an index. It's going to remove whatever item is at index 3 in the array list. Let's run it. Okay, so here's my original array list. I had 5 items in it: Shane, Anthony, Nick, Don, Christina. It's going to remove whatever is index 3. So an array list is 0 based, right? It's an array underneath. It's 0 based indexed. So 0, 1, 2, 3. So I'm going to remove Don. Did it remove Don? Let's look at it. Shane, Anthony, Nick, Christina. Don was removed. It removed index 3. Perfect. Pretty simple. So what did you learn about array lists? Well, array lists are pretty much like arrays, except they're a little bit better. They manage things for you. With an array, I have to keep track of what is my next index when I'm adding stuff to it. So I can easily add stuff to the next index. I have to keep track of that variable. So with array, when I'm adding stuff to an array, I have to keep track of what index I'm at, and I have to add it at that next index that's empty, right? I have to keep track of that myself. An array list does that for you. With an array, if I remove stuff, I've got to remove something. If I remove it out of the middle, I've got to bring all the other data elements up in the array to make sure that my empty slots are on the end of the array. An array list does that for you. An array, if my array gets full, well, I have to create my own new array that's bigger, copy data out of my old array into my new array, throw my old array away. Well, an array list does that for you, right? So the array list adds on features to an array. Oftentimes, an array list is called a dynamic array because it can grow on its own, and you don't have to manage that. More times than not, you will use list over arrays. And when you do use list, more times than not, you'll most likely be using array list. Now, in our upcoming lessons, we're going to go over other types of data structures. We're probably going to go over a set next. All right, hey, so let's go ahead and get started. First things first, what is a set? In computer science, a set is an abstract data type that can store unique values without any particular order. Now, the key thing to note here is unique values. So in a previous lesson, I went over lists, specifically array list. Now, array list or list can have the same value more than once. It's not unique. The key thing to remember with sets, well, it's going to be unique values. You cannot insert the same value into a set more than once. It will just ignore the duplicate value. So that's a key thing to note about sets. All right, hey, let me show you an example of how to do this. All right, so on my desktop here, I've got some examples already made up. We're going to go over those one by one. I'm going to go pretty quickly. Let's uncomment this. Now, I'm creating a set. A set's an abstract type. What does that mean? Well, in Java, that means it's an interface. So I have an interface called set. Any class that implements that interface has to implement certain features that the interface defines. A set is an abstract type. Now, in this case, I'm going to use the concrete type of Hashset. I'm going to show you how to create a Hashset. In order to use the set interface and Hashset, I have to import them in Java. So you'll notice up here, I'm importing javautil.hashset and I'm importing javautil.set. Let's look at how I create this Hashset. I'm going to do set, and using generics, I'm going to say I want my set to contain strings. So I'm doing set less than string, telling it what I want it to store, greater than sign. Then I'm going to define my variable, users set, and I'm going to say set, I want to say create a set of strings, call it user set. It's equal to new hash set. So here I'm saying I want my set to be a hash set underneath. I've got my less than and greater than sign here. You'll notice that I have string there. With certain versions of Java, you don't have to say that twice. So I'm going to get rid of that. So I have equals new hash set less than greater than open parentheses, close parentheses. So I'm creating a hash set. I'm setting it to the variable called users set. Now, how do I add data to the set? Well, much like a list, exactly like a list, you can just add data to the set. So I'm going to do user set dot add Shane. I'm adding the string Shane. I'm going to do users set dot add Christina. I'm adding the name Christina. User set dot add Nick. I'm adding the name Nick. So in the previous lesson where we went over a list, you'll see this worked exactly. This works exactly the same way as a list. I'm adding things to this data structure, to this collection. Let's run it. And there I go. So I have a hash set. It's got Shane, Nick, and Christina. I have a hash set that contains these 3 items. What happens if I try to add a duplicate into this collection, right? What happens if I try to add Shane in there more than one time? I'm going to uncomment this code. So I'm using users add Shane, user add Christina, user add Nick. I'm printing it out, and then I'm going to add Shane again, and then I'm going to print it out. Let's see what happens. The first time it printed out, it got Shane, Nick, Christina. The second time it printed out, we have Shane, Nick, and Christina. It didn't add it. You can't have the same value in the set more than once. It won't let you do that. That's the key feature of a set, unique values. Unlike a list. A list would have let me add that item in there more than once. Key thing to note. Sometimes the difference between whether you want to use a list or a set is that key factor. If you want to make sure your data is unique, use a set. Don't use a list. All right, well, how does it know whether it's unique or not? How does it know whether what it's adding is unique or not? Well, a hash set, I believe, has a hash map underneath. Correct me if I'm wrong. And before it hashes that value at, it's going to hash that value. It's going to put it into a certain slot in a hash map. It's going to use a hash to do that. So before it puts it into a slot, it's going to take whatever value is already there, if there is a value, and it's going to compare. It's going to compare using the dot equals method. It's going to take the current value of Shane. It's going to say Shane dot equals Shane. And if it equals, it's not going to insert. It's not going to keep both values. It's only going to keep one. Not sure I explained that well, but key thing to notice is it uses equals. A hash set uses equals to determine whether that value is unique or not. So that's a key thing to remember. Equals. So does Shane equals Shane? Let's run that real quick. And of course, it's true. Shane does equal Shane. That's what it does underneath. That's how it knows to throw one of them away. Move to the next example. How do I know if a hash set contains a value already, contains a certain value already? Well, the hash set or set interface has a contains method. This will tell you whether a value already exists in the set. Let's run it. Does user set contains Shane? True or false? Let's run it. So there's my true. It does contain Shane. How about Advil? Does user set contain Advil? Let's run it. And false. Does not contain Advil. So this contains is taking this Advil and using the dot equals to see if it's equal to other values in the hash set. Let's move on to the next example. How do I get the size of a set? How do I know how many elements are in a set? Well, just like with list, you have a size method, dot size. Okay, an array has a dot length property. A list has a dot size method, and a set has a dot size method. This is going to tell us how large our set is. Let's run it. My set is 3. I have a set with the size of 3. There's 3 items in my set. Let's move to the next one. How do I remove something from my set? So just like list, you can remove something from your set by passing in the value you want to remove. It will look into your set and find the value, and if it's there, it will remove it for you. So I want to remove the value of Shane from my set. I do user set.remove, and the value I want to remove it. If that value is there, it will remove it. Let's run it. So you'll see here, I printed out my set. I printed it out after I removed Shane. At the very beginning, I had Shane, Nick, Christina. Now I only have Nick and Christina in my set. So dot remove went to your hash set and it removed that value of Shane. How do I know if my set is empty? Well, a hash set has an isEmpty method in it. A set has an isEmpty method. So this will tell you whether your set is empty or not. Let's run it. Is user set is empty equals false. It's not empty. We know that it has Nick and Christina in there. So false. The set has all these helper methods on there to help you do certain things. Pretty neat. Let's look at how do I empty my set? How do I clear all of my set out? I could use the dot remove on each element in my set, but I don't want to do that, right? So how can I just clear it out altogether? Well, a set has a dot clear method. So when you call dot clear, it's going to clear everything out, I think. Let's run it. Let's see. I did user set dot clear, and then I did is user set empty. Is it empty? Well, before the empty was false because it had Nick and Christina in it, and it was false. I cleared it out, and now is empty is true. So it cleared it out. All right, I'm going to comment that back out. How do I iterate my set? How do I go through each value in my set? Just like with a list, you can use a for each loop. So I have for string user in user set. For each user in user set, system out print that user. So I'm using a for each loop. Let's run that. And you'll see it's printing it out here. Nick and Christina printed out each of my users in that set. All right, next. What's another way I can loop through my set? Well, a set, you can also use user set for each, and you can use a lambda expression. System.out : print line. That's basically saying call the method print line on system.out, pass in for each user. So pass in each user in the user set to this method print line on system.out. So this is using a lambda expression. It's using basically a for each on that collection. You can also do this with list. I didn't show that in the previous lesson with list, but you can also do this with list. I'll put a video up here. It talks about lambdas, lambda expressions. If you're not familiar with lambdas, really neat stuff, really cool stuff. I'll put a link here, somewhere in here. Go check that video out. I also put it at the end of this video. Check it out. Pretty neat stuff. So what will this do? This is so for each user in user set, call the system out print, right? That should be what it does. All right, let's run it. Here's my first for each. I printed out Nick and Christina. Here's that for each using the lambda expression. Let's move on to the next one. All right, so let's look at a different kind of set. So far we've been using a hash set. Now there are other kinds of sets. I'll briefly touch upon those sets. Next is a tree set. What's the difference in a tree set and a hash set? Well, one key difference is when you're adding stuff to a hash set, or you're removing stuff from a hash set, or you're running the method contains on a hash set, it's O1 time. It's constant time. It's big O of 1, because underneath that hash set is a hash map, and hash map is for the most part O of 1, big O of 1, constant time. It's very fast, right? So that's a hash set. Now, the key thing about a hash set is even though you have unique values, they're not in any order. There's no order to those values. You can't order those values. This Shane, Christina, Nick order does not stick around. If this was a list, these items would be in that insertion order, okay? Since it's not a list, it's a hash set, there is no order. The values will be unique, but they won't be in order. If I were to move, let's put Nick above Shane here, get rid of it there, and let's run it, we're going to see that Shane is still shown first there, Nick is next, and then Christina, even though I'm putting Nick in the set first. So basically a hash set does not keep order, does not keep insertion order or any other kind of order. But a hash set does provide the uniqueness of values because it is a set, and it's super fast for adding, removing, containing, because inside the hash set there's a hash map underneath. That's the key features of a hash set. Let's go down to this tree set. So on this tree set, well, what's the difference? Well, a tree set isn't as fast as a hash set because it doesn't use a hash map underneath. It uses a tree underneath. In Java, a tree set uses a red-black tree. That's the particular data structure. It's too advanced for me to go over in this video, but just know that a tree set uses in Java a red-black tree underneath. With a red-black tree, most operations on that red-black tree are going to be O log of n. It's going to be big O log of n. Okay, that's a logarithmic time. So an add, a remove, or contains call on a tree set is going to be big O log of n, logarithmic time. It's not as fast as a hash set. It's not as fast as big O of 1, constant time. It's big O log n, which is logarithmic time. So that's one thing to note. A tree set is slower, not as fast as a hash set. But what's the benefit of a tree set? Well, you still get your unique values. It is a set. The benefit is there's some order to this tree set. Okay? When you insert something into the tree set, it's going to use the compare to method on each object you insert, and it's going to use natural ordering to order stuff in the tree. So here I'm adding Shane and Christina to the tree. What do you think is the natural order of Shane and Christina? Alphabetical order. I think Christina should go first, right? So I'm putting Shane and Christina. Let's print that out. Let's see what it does. Now if I look at the tree set, what's first in the tree? Christina. It's natural order. In this case, natural order is alphabetical order. Christina and Shane. It's using a compare to on each object to know what the natural order is. And it's going to keep whatever you insert into that set in a natural order. Sometimes you have a process or operation where you want values to be in a certain order. A natural order sometimes fits the bill. So this is the benefit of a tree set. You have ordering. It's a little bit slower than a hash set, but you still have uniqueness and you get ordering. That's the benefit of a tree set. A hash set, you don't get any ordering. That is a tree set. A hash set uses a hash map underneath. A tree set uses a red, in Java, uses a red-black tree underneath. All right, let's look at one more set. So before we end the lesson, let's go over one more set. I've got a linked hash set. So we've gone over a hash set. We've gone over a tree set. All right, they both provide a way to collect data, sets of data. They both provide uniqueness. A hash set is faster than a tree set, but a tree set has a natural stores things in a natural order. What's different about a linked hash set? Well, a linked hash set has a hash set underneath. It's also almost as fast as a hash set. The difference is a linked hash set provides ordering. Now, what type of ordering does it provide? Its ordering is based upon insertion order. So a linked hash set not only uses a hash set underneath to store the data, but it also uses a linked list. Okay, so that's why I say it's almost as fast as a hash set. It stores the data in a hash set, but it also links it together. Okay, so it keeps ordering. It keeps the insertion order. Now we saw a tree set keeps a natural order, and a hash set doesn't keep any order. Well, a linked hash set keeps insertion order. So more times than not, you may not need a natural order. You may want to keep the order of which you insert stuff into the set. Well, if you need to do that, a linked set is the way to go. It's almost as fast as a hash set. With a tree set, we saw if I added Shane and Christina and printed it out, it's going to put Christina first because C comes before S, or natural ordering. Now in this case, it should put Shane first because that's the order of which I inserted it. I inserted Shane first. Let's see if that works. Linked hash set. Inserted Shane and Christina, right? Now let's say I added one more. Users linked hash set dot add, and I'm going to put Adam, right? Well, if this was a tree set, natural ordering would put Adam first. Since it's a linked hash set, it should preserve the order of which I inserted the data. That's the order it should be. Let's run it. Now you notice it's Shane, Christina, and Adam. It's keeping the order of which I inserted items. So I get my uniqueness from having a set. I get to store a collection of data, but I get to store it in a certain order, the order of insertion. Pretty neat. It's almost as fast as a hash set. It's big O of 1. Constant time, pretty fast, almost as fast as a hash set, other than you have to maintain a linked list also. So it's pretty fast. Now, what if I were to change this to a tree list? So we see now it's keeping the insertion order, Shane, Christina, Adam. If I change this to a tree list, a tree set rather, what's going to happen? The order should be natural order, which would be alphabetical order. So I'm going to run it. So this is no longer a linked hash set. It's a tree set, and it's in natural order. Adam, A first, C next, Christina, Shane next, right? Tree set, natural ordering. A linked hash set uses the insertion order. Key things to note. Let me change this back. We've gone over what a set is. It's an abstract data type that stores a collection of unique values. One way of implementing that is hash set. Hash set uses a hash map underneath. There is no particular ordering. It's constant time, big O of 1. You can also use a tree set. Tree set is logarithmic time. It's big O of log n for most of its action. It does keep things in order. Keeps things in a natural order. With strings, that's alphabetical order. Another type of set is a linked hash set. Almost as fast as a hash set, but it also keeps order, unlike a hash set. The linked hash set keeps the order of insertion, which is sometimes better than your alphabetical or natural order. Those are 3 different types of sets. So that's it for today. I hope that makes sense to you. If you have any questions, leave me a message below and I will definitely get back to you. Again, my goal is to help others learn how to program. So if you have a question, leave me a message below and I'll get back to you. If you enjoyed this video, if it was helpful, hey, click subscribe, click that like button. It helps me get this video out to others so others can be helped also from this information. Hey, again, thanks for watching. Have a great week.